All right, so picking up where we left off, we we're talking about frequency histograms, or we had gotten up to that point, okay? And so you should be on page. Sorry, I'm going backwards, but I'm not quite sure what page we should be on. Okay, we should be on page 46 and 47 are going to be, it's going to be histograms, okay? So let's go ahead and on page 46, you should label that histograms or frequency histograms, okay? And so you are going to be writing this into your notes onto your page, okay? And these are the different properties that come down to when you're actually drawing histograms, okay? So the thing is you want to find the lower and upper boundaries of each of your classes because histograms, to be honest, are normally drawn with grouped frequency tables or frequency distributions. So you want to find your lower and upper boundaries, okay? Just like how we did on this example right here from the green foldable where we found the upper boundaries of the first class and the last class. You want to find the upper and lower boundaries of each class in order to perform your to create your histograms. And then those boundaries are going to be exactly where those bars are because a histogram is nothing but a bar graph except where the bars are touching. So that third point where it says there are no spaces in between bars, the reason is because the upper boundary of one class is the lower boundary of the next class that follows it. All right, and then on the x-axis, when we label it, is actually going to be your class boundaries, and then the y-axis is going to be your frequency values. So we have three examples that go along with frequency histograms. That was the pink sheet and the white sheet that had the grids that you guys cut out the other day. And so it's going to span between these two pages, 46 and 47. So if you want to do any additional notes or if you want to add anything to the lines, you have the space because between these two pages you're going to fit the three. You're going to fit the three examples with the grids, okay? So let's look at this first example, which is going to be shoe size. And we're going to be drawing the histogram to match this, okay? Now, we have already kind of started this with that example from the green foldable where we were finding the upper and lower boundaries of each class, okay? Now, the thing is that when you are, again, when you're finding the upper boundary or the lower boundary, remember you want to take to find lower boundaries, you want to take the lower bound of the class that you're working with and the upper bound of the previous class, and then you want to find the average. Now remember from our last example, the number before was 14. And so when we're trying to find we got to find the average between these values. So between 14 and 15, remember that boundary was 14.5. Okay, and then you want to continue to do that. You want to continue to find all your lower boundaries, okay? And so we're going to look at, okay, let's look at the lower bound of the second class and then the upper bound of the first class and find the average. Okay, well, the average between those two, 19 and 20, is 19.5. Remember, we find this by basically adding those two together and then dividing by 2. So 19 plus 20 divided by 2 is 19.5. And we continue this process again. We take the lower bound of the third class and then the upper bound of the class before, which was the second class, and we find the average between those two, and that's going to be 24.5. Now, hopefully you start to realize that, yes, it is basically going to be, the halfway point between each of the two numbers. So continue the same process. The next one's going to be 29.5. The one after that is going to be 34.5. And then the one after that is going to be 39.5. Okay? And if you notice, the spacing between the lower boundaries is the class width of this particular frequency table. All right. So now to find the upper bounds, we do the exact same thing, just with the upper bounds. So for the first class, the upper bound, we take the upper boundary, we take the upper limit of the first class and then the lower limit of the previous class. And if you notice, Yes, it is the same as the lower bound um, of the second class. Okay, the upper bound of the second class is the same as the lower bound of the third class. This is what causes your frequency bars not to touch each other. Okay, or sorry, it's what actually cause your frequency bars to touch each other. Okay, because they share, basically the upper boundary is shared with the lower boundary of the next class. Okay, and so repeating this process, the next one's going to be 29.5. Again, it's the halfway point between 29 and 30. The next one that's going to be 34.5. The one after that is going to be 39.5. And then the one after that, if you recall, we take the upper bound of the fourth class and then the lower bound of the next class if there was to be one, okay? Now that value, as we know, would be 45. And so then the halfway point between that and 45 and 44 would be 44.5, okay? So these are going to basically be the x-axis values, okay? Or not the x-axis values, that's going to be where we plot our bars, all right? And so I went ahead and drew my x and y axes. You guys should do the same. At this point, you should have your table glued down and your grid glued down, and you're probably going to have to end up actually writing on the notebook pages your scale, okay, and your labels. And whenever you're drawing a graph yourself, you always want to make sure that you label your x and y axis. You want to make sure you label your x and y axis, okay? And you kind of want to make it you also want to make it consistent. Remember, this break right here basically means I'm going to be skipping some numbers and then starting later on down the line, okay? Because normally right here where the x and y axis intersect is 0, 0. And so since my lowest shoe size is 15, I am going to start with 15, and that's why I have the break there. On your y-axis is going to be your frequencies. So I'm going to pause the video and I'm going to fill everything in. Okay, as you can see here, I went ahead and labeled my x-axis going by 5s after I start with 15. And then I labeled my y-axis going by 10s. My x-axis is labeled shoe size and my y-axis is labeled the frequency. And that is how, you always want to make sure you label your x and y axis. So now at this point, I'm going to go in and I'm going to draw my bars to represent my lower boundaries and my upper boundaries. So the first one, the first class is going to be in between 14.5 and 19.5. So that's going to be a little bit before, it's going to be a little bit before 15, and it's going to be a little bit before 20. And the height of that is going to be 3. All right. Now this isn't, a specific, type of grid where you have it's not like the centimeter paper where you have like the little individual lines, but so right now we're just pretty much going to guesstimate that this is about 3. And there's my first bar from my histogram. Now the next class is going to be in between 19.5. So again, it's a continuation of the upper bound of the first class. So it's going to be at 19.5. And then the next one's going to be at 24.5. So it's going to be a little bit before 25. And then it's going to have a height of 9. And then there's the next bar. And this process just continues. The lower bound of the third class is the upper bound of the second class. Okay, it has a height of 12. And it's going to be in between 24.5 and 29.5. And we just continue from there. Okay. And as you can see, the bars are touching each other because, again, they are sharing that boundary. Now, this is very important, okay? I'm not putting these vertical bars at 30 and 35 and so on and so forth because that is not where they belong, okay? That's why you find the upper and the lower boundaries. Okay, the next one is 45, so I'm kind of going all the way up here, about halfway. I know you guys can probably hear my dogs in the back. There's a growling, so I apologize. And now for the last class, which goes from 39.5 to 44.5, and it has a height of 31. And we have just created our histogram for these shoe sizes. All right, all of our bars are connected. They have our upper and lower boundaries. My x-axis is labeled and my y-axis is labeled. Here's the second example, okay? There are some questions. There's a question that we have to answer before, and it says write down the lower and upper boundaries of the fourth class, okay? So remember, your fourth class is 1, 2, 3, 4. So it's this one right here. Let me fix that. So it's this class right here. And so I need to find my upper and lower boundaries. So you guys go ahead and do that. Pause the video and find the lower boundary and upper boundary of that particular class. Press play when you're ready to check your answer. Did you guys get 15.5 and 20.5? I hope you did, because remember, you were taking the lower bound of the fourth class and comparing it with the upper bound of the third class and finding the midpoint, the average. And then to find the upper bound of the fourth class, you're going to take the upper limit of the fourth class and the lower limit of the fifth class and find the average between those two. Now to draw our histogram, we're going to need all of the upper and lower boundaries. So you should go ahead and figure out what those are and then go ahead and graph it. So find your upper and lower boundaries. Okay, and if you want to check to make sure you're right, you can press play. Okay, so I'll have, because I'll have that following next. And then you should draw your histogram after that. So here are your your lower and upper limits for this particular data, talking about the number of bands. And now I'm going to draw my histogram, and you should be doing the same. All right, and I decided to label my my axes this way. Of course, I included my my labels of number of bands and frequencies, and you should do the same. I decided to go do my x-axis by 5s since my lower bound is at 0.5. There was no need to do the little break because I'm basically almost at the origin. And the beauty about doing this and gluing it in, I needed another line. I didn't have enough, so I went ahead and drew that. Now, would I encourage you to do that on a test? No. I would do a better job of making sure that you guys had enough space to draw your histograms. Okay, but you guys will probably had to add in an extra bar. All right, for your notes. Okay, so now I'm going to go through and I'm going to draw my bars. I am going to pause the video, and you should do the same. And you should try to do the bars yourself, and then check it. Okay. And then check it after. If you get stuck, then yes, you can press play and watch the rest of the video, but really try to do it yourself. So again, I have all of my bars are touching. I have them at my lower and upper boundaries, and there's my histogram for this one. All right. You have one more. You guys are going to do this one on your own. Remember, you were spreading this out between pages 46 and 47. So go ahead and do this one. And yeah, pause the video. Do this one. Now, hopefully you didn't get stuck on your upper and lower boundaries. Hopefully you still went through and did the same process. Now, this one, if you notice, there's no space in between. So finding the average between the two is not necessary because the upper boundary of the first class and the lower boundary of the second class is the same. So that means the upper boundary is literally going to be, 10 o'clock. And the lower boundary of the second class is going to be 10 o'clock. The lower boundary of the first class is going to be 9 o'clock, and so on and so forth. Okay, so this one is actually going to be, they were already going to be touching because they share that that upper and lower limit. Okay, so continue to finish drawing this histogram. All right, and I trust that after doing the first two examples, I'm pretty sure you guys got this third example down and under wraps. Okay. So I'm not going to do this one. I'm going to go ahead and continue forward with measures of central tendency. So go ahead and update your table of contents. On 49, we're going to do measures of central tendency. And then on 50 and 51, we're going to do frequency tables, measures of central tendency. All right, so on page 49, you should title it Measures of Central Tendency, and make sure you get down the goal, okay? Because for the histograms, we were finishing off the goal from the other day, and today you guys are going to be able to find measures of central tendency of data. And what is measures of central tendency? Well, you guys actually be quite surprised, but it is mean, median, and mode. You guys should have received this foldable, and so we're basically what you're going to do is you are going to basically cut out around the circles. Okay, so cut around the solid, and you're going to fold at the dotted to basically create like a little petal. All right, and so go ahead and pause the video, cut it out if you haven't already. And hopefully you did not need me to put up these definitions. You already knew that the mode is the value that appears the most. The median is the number that's in the middle once you put it in order. And then, of course, the mean is also known as the average. You basically add up all the values and then divide by however many data points you have. So here's an example that we're going to go ahead and work out. Okay. So given all these different data values, we want to find the mode, we want to find the median, and we want to find the mean. Now, considering that I need to, for the median, I need to put these things in order. I'm going to go ahead and I'm going to put these bad boys in order. All right. So let me do that now. All right. I'm just going to double check this. All right, and we are good to go, okay? So the mode, as we can see here, the mode is the number that appears the most, and that number is going to be 4, okay? The median is going to be the number that's in the middle once I, kind of, yes, you can go through this old school canceling. Okay, that cancels out with that with that. I'm just going to continue this process all the way through. As we can see, the number in the middle is going to be 5. So our median is a 5. All right. And hopefully you remember also too from your like your elementary days of doing statistics, mean, median, mode, is that if it just so happens that there's actually 2 numbers that are in the middle, you always take the average of those 2. Okay, so if I ended up with 5 and 6, I would have done the average between 5 and 6, which would have been 5.5. And now the last thing to find the mean, what we're going to do is we're going to total all those numbers up together, and then we are going to divide by 11 because that's what we have, okay? So I'm going to go ahead and just for the sake of, simplicity here, we know that we're going to basically total up all of these, add all these up together, and then we're going to divide by 11. So this is 66 divided by 11. And so our mean is going to be 6. Okay? Now I know some of you guys are like, Miss Anderson, now you know IB is going to try to trip you up and all this other stuff. Okay. Yes. Yes, it is. Okay. But they're not going to try to trip you up. But the truth of the matter is they're not that simplistic. This is something that you did back in elementary school. Okay. So yes, they are going to step it up a notch. All right. So you're about to get 3 examples that you are going to handwrite in. Okay. 3 examples. If you want to kind of fast forward a little bit through the videos, kind of see how long they're going to be and how much spacing you need, then that's fine. Go ahead and do so. But all 3 examples should be able to fit inside of this particular page. All right, so go ahead and glue down this foldable and excuse me, so you can have your spacing already for these next 3 examples. Okay, so here's the first one. For these data, the mode is 5, the median is 6, and the mean is 6.5. And so you have your data set. And yes, it is in order from least to greatest. So given that S is less than T, find the value of S and T. Well, since we know that the mode is 5, that means that 5 has to appear the most. And right now we have 2 5s, just like we have 2 1s, and just like we have 2 12s. So in order for the mode to be 5, that means that S would have to be 5. Okay? Now that would be something like a write down problem because, it is just as simple as recognizing that in order for 5 to be the one that shows up the most, S would have to be 5. And that kind of also lets us know that T is going to have to be a number that's bigger than 5. All right? So how do we go about finding T? Well, since we know that the mean is 6.5, that means that the sum of all the numbers divided by however many numbers we have, which we have 1, 2. We have 14 numbers. Sorry, I had to count them. That means the sum of all the numbers divided by 14 should equal 6.5. Okay? Well, what is the sum of all these numbers? Okay, let's go ahead and let's add that up. Hopefully you guys did it as well. Did you guys get 80? Because that's what I got. It was actually 80 plus T, okay? Because T, and I'm going to use a different font so then that way it actually looks like a T. There we go. All right, so we have 80 plus T because we're able to add all the actual numbers, including making S5. Okay, so that ended up being 80 plus T, and we're still going to divide by 4. And basically what we have is we have a nice simple equation that we can go ahead and solve. Okay, so we need to get rid of the denominator, so we're going to multiply 14 on each side. So it's going to be 14 times 6.5 equals 80 plus T. 14 times 6.5 is 91. So this is basically 91 equals 80 plus T. And then we are going to subtract 80 from both sides and find out that T is equal to 11. All right. And that's your answer. T is 11 and S is 5. Here's the second example out of our 3. It says Jen obtained marks of 76, 54, and 65 on his physics, biology, and history exams, respectively. Remember, respectively basically means, the order that they were in is the order how they match up. So he got a 76 in physics, a 54 in bio, and a 65 in history. It asks us to calculate the mean mark for all 3 exams. Well, the mean mark is very simple. All we do is we take all 3 exams, we add them up, and then we divide by the number of exams that there are. So that's 3. So 76 plus 54 plus 65 is 195. And we're going to divide that by 3 to find his mean, aka his average. So his average was a 65. He got us basically an average of 65 for all 3 of his exams. Now, B asks us to find the mark that Jen must achieve on his math test, his math exam, so that the mean mark for all 4 exams is exactly 68. Okay? So he wants a mean of 68, which means that when he adds up all 4 tests, his physics, his bio, his history, and his math, whatever it is, that when he actually does the average of those 4 tests, it should equal 68. Okay? So we're going to basically add up all those values, include the math, and then divide by 4. Now again, we're dividing by 4 because once we add in that math test, we go from 3 exams to 4 exams. And now we're going to go ahead and multiply both sides by 4 to get rid of that 4 in the denominator. And again, those first 3 tests add up to be 195. 4 times 68 is 272. So that's going to equal 195 plus M. And then we're going to subtract 195 from both sides to find out that in order for him to get an average of a 68, he has to score a 77 on his math exam. All right? Hopefully you guys are doing okay on these questions. Yes, these are more like your IB questions that you're going to get when it comes down to mean, median, and mode. And I know the last 2 have been basically about mean, because let's just be realistic here, okay? Find the median and find the mode. Those would be like a 1-point type question. It's the mean ones that are going to be the thick ones, the juicy ones. And here's our last example, okay? The last example you guys are going to write down that's going to go on this particular page. It says Zoe and Sean compared their test scores. Zoe had a mean of 81 after taking 5 tests, and Sean had a mean of 78 after taking 3 tests. Okay, so Zoe took 5, Sean took 3, and they had their respective averages. And it said each of them, that should say them, took 1 more test and ended up with the same mean score of 80. So question A asks you to find the grade that Zoe gained on her 6th test in order for them to have a mean score of 80. And then for part B, you have to find the grade that Sean gained on his 4th test so that he could have a mean score of 80. All right, so it's almost like you're kind of treating them a little bit separately, but Zoe took 5 tests and Sean took 3 tests. So in order to do this one, we have to think about this, a little bit outside the box. because Zoe took 5 tests and he scored an 81 on them, an average of 81. So we don't know if it was, a 79, a 95, and then a 60 something or whatever. We don't know what those individual 5 scores were to average an 85. But we do know that he took 5 tests and the average was an 81. So it's very, very possible that all 5 tests were an 81. Because think about it, if you do 81 plus 81 plus 81 plus 81 plus 81 and then divide it by 5, you're going to get an 81. So we can do that. We can multiply 5 by 81 and then basically get the total of all 5 tests. Okay? Then he took a 6th test, which I'm going to label X. And when he took that 6th test, his average became an 80. So to solve this problem, this is exactly how we would set it up. 5 times 81 to represent the sum of the first 5 tests, plus X, some score of a 6th test, divided by 6 to get us an average of an 80. And so from here, now that we have our equation, we work it out. 5 times 81 is 405, plus X equals, I'm going to go ahead and multiply 80 by 6 to get 480. Again, multiply 6 by both sides to get 480. And then I'm going to subtract 405 from the 180 to find out that in order for him to get a score of an 80, a mean of an 80, he had to score a 75 on his 6th test. And you would do something similar for Sean to find out what he would have to score on his 4th test to get a mean of 80. So I'm going to pause the video here. I want you to do something of a similar format to figure out what Sean's 4th test, his score on his 4th test is going to be. Hopefully you got 86. But Sean needed to score an 86 on his 6th test in order for his average to be an 80 as well. All right? And that's the bulk of measures of central tendency. It is your basic mean, median, and mode. And we already went over histograms and things like that. And actually what I'm going to do here is I'm going to stop here and we will do mean, median, mode measures of central tendencies for your group frequency tables, aka your frequency distributions, when I come back. If you have any questions, message me on Schoology.